In this video, we're going to talk about finding a confidence interval for the mean, but this time the population standard deviation is unknown. Now the process is going to feel very similar. We're going to look at our sample, we're going to find our sample mean, then we find our margin of error and we subtract it to get the lower bound of our confidence interval. We add it to the sample mean to get the upper bound of the confidence interval. The only difference is in the formula for how we calculate our margin of error. If you recall back on page 300, our previous formula for finding the margin of error included the population standard deviation. So if we don't know that information, we have to come up with a new formula. Not only do we use a new formula, but we actually are going to start using what's called the t-distribution instead of the normal distribution. Now, they're very similar, and we're not going to go really into depth about the t-distribution. But this is on page 310. You can see some pictures of the t-distribution, and it looks like really close to a normal distribution, just the tails are a lot thicker as we go off in the tails. But as our sample size increase and get bigger and bigger, the tails start to get smaller and smaller, and eventually it'll be almost identical to the normal distribution. Another thing that goes along with the t-distribution is something that's called degrees of freedom. And to calculate it, it's really easy. If your sample size is 25, your degrees of freedom is 24. It's always just one less than the sample size. And this little inset here on 310 kind of illustrates what the degrees of freedom mean. If you have 25 things in a sample, it's like having 25 chairs in a classroom and 25 students. The first 24 students have freedom as to where they sit. But that last student has no choice. There's only one chair left. They have to sit there. So the people with freedom is always one less than the sample size. The degrees of freedom is one less than the sample size. Our steps for creating the confidence interval are listed here on page 312. They'll look very similar to the ones on page 301. Back on 301, we knew the population standard deviation. These are for when it is unknown. The main difference is going to be here, step 3 and 4, where instead of using the previous calculations for margin of error, which were back on page 300, we're going to use this formula, which instead of having the population standard deviation on top, it has the sample standard deviation on top. And instead of using the z-distribution, it uses the t-distribution. Now, lucky for us, we have technology. So these steps, we're going to just plug in our numbers from the problem, and technology will tell us what our margin of error needs to be. So to walk through example 2 on page 312, we randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample mean temperature is 162 degrees Fahrenheit with a sample standard deviation of 10 degrees Fahrenheit. So let's plug in what we know so far. Our sample size is 16. Our degrees of freedom is going to be one less than the sample size, so it's 15. And this problem came out and told us what the mean was for our sample. Our sample mean is 162 degrees, and our sample standard deviation is 10 degrees Fahrenheit. Sometimes you may need to use Excel and like a listed table of data to figure these values out, and sometimes you'll just know them like we do in this problem. Alright, so we're trying to construct a 95% confidence interval for the population mean temperature of coffee sold. And we're assuming the temperatures are approximately normally distributed, which we needed to know that because our sample size was less than 30. If you recall our very first step, we either need to know the population is normally distributed or our sample size is at least 30. And so now to find the margin of error, we use the formula here. And Excel will handle it all for us. We just have to type in the arguments, the input that it wants. So we use the formula confidence.t to let it know that we're using the t-distribution, which we have to use whenever we don't know the population standard deviation. And the first thing we enter is alpha, which if we have 95% confidence, then our alpha is 5%, so 0.05. Our next input is the sample standard deviation, and then our final input is the sample size. So when I put an equal sign in front of that, Excel will calculate it for me, and I get 5.33. And to match up with the book, let's just use one decimal spot, 5.3. And then we're going to construct our confidence interval like we have been. Our sample mean goes in the middle, and then we take that sample mean and we add B5 there, the margin of error. That gives us our upper bound of our confidence interval. And then we take our sample mean and we subtract our margin of error to get the lower limit of our confidence interval. So with 95% confidence, you can say that the population mean temperature of coffee sold is between 156.7 and 167.3.